Okay, so 8/6 is radical expressions, so that's one part of what we're talking about. And rational exponents. That sounds kind of cool, a little tongue twister of sorts, but really what we're talking about is radicals. And rational exponents means that like we have some number raised to a fraction. That's what that word rational implies, that word ratio. Question for you is it easier to read an expression written in radical form? So written like this? Or would you rather see it written with rational exponents? And for me, sometimes it's easier for me to go, oh yeah, I recognize that fraction, or oh yeah, I recognize that radical. So depending on what the problem is, it might be easier to deal with it one way versus another way. But you have to find out what you like, because we can write every problem both ways. Before we get into how we do that, let's talk about radical expressions first. Right? You've seen a square root. And with that square root, we can kind of extend that to to radicals in general. Okay, so we have like a general form for our radical. And what it looks like is this. Okay, so that piece underneath the radical is called our radicand. And this little number here is our index. Now I'm going to use green for my index all the time. Throughout this whole thing, green will be my index. Okay? The other symbol kind of looks like a funny looking house almost, maybe like a lean-to or a shanty, is our radical symbol. Okay? You've seen this before. That's a square root. And for a square root, the index, we understand the index to be 2. That we never write that 2, although those of you who have an iPhone, you see a 2 when you look at it. We also can talk about...
Please, Trayvon Reed, if you are in the building, please come to the security desk by the junior high doors.
We can talk about Trayvon Reed.
Please come to the
We can talk about the cubed root.
Junior high doors for your ride. Thank you.
Where we put a 3 as the index. We can talk about the 4th root. We can talk about the 5th root, and so on. For example, the cubed root of 8 is 2. So the 4th root of a number like, let's say 625, is going to be 5, because 5 times 5 times 5 times 5 is 625. Since 5 to the 4th is 625, the 4th root of 625 is 5. Okay? Now, what's really cool is you can also write some of these in a little bit different way. Let's say I'm just going to put an X under each of these to make it easier for us to talk about. Okay? Now, the square root of x can also be written as x to the 1/2. Cubed root is x to the 1/3. X to the 1/4, x to the 1/5. These two things, these two, these two, these two, and these two, so these 8 things, whatever, all mean the same thing. We can, when we see x to the 1/2, we need to be able to think square root. These are both ways of writing square root. These are both ways of writing the cube root. These are both ways of writing the 4th root. And really, as we look at that with that fraction, that's that whole fantastic rational exponents thing that we started with. This whole radical expression, every radical expression can be written as a rational exponent. And let's talk about kind of how that looks here, right? So here's what I mean. Every radical expression, so let's say I have a radical. And under my radical, by the way, my radical has an index of n. Remember I said anytime I use green, I'm going to use, or anytime I do the index, I'm going to go with green. And then let's say for some reason I'm raised to a power under here. I can rewrite this as x raised to the m divided by n. Notice the index of my radical is the denominator of my fraction. And so we can change all that. Now I'm going to put a couple of rules on this. First rule, treat it as greater than or equal to 0. And actually, you know what? Not even equal to. It doesn't make sense to have 0 because that's just going to kick out 1. So I'm looking greater than 0. Right? We don't deal with negative exponents. We treat them as the reciprocal. So m is going to be greater than 0. Now n. N's got to be greater than or equal to 2 for our index. And n has to be a natural number. 2, 3, 4, 5, 6, and so on. Okay, so that's some rules on our index. Now, let's actually practice and take a look at what this looks like. I'm going to give you 3 examples, okay? The first one is the cubed root of x to the 9th. The second one is the 4th root of x to the 17th. And my 5th one's going to be the square root of 16x to the 5th. Okay? Now, all of these I can change into fractional form. I need to know what the index is, and I need to know if there's any exponents on any of my radicands, the numbers under the radical. So when I see that, I go, okay, I see my 9, I see my 3. Why did I write equals? That was dumb. X to the 9 over 3. Now, you're all brilliant people. You know 9 divided by 3 is 3. So then really I can simplify that to be x to the 3rd. Okay, put it on pause, get B and C done real quick. Take about 10 seconds and make that happen. How'd you do? I hope you checked them, and I hope you're able to make it happen. Let's check real quick. Notice I need to identify my index. Not wiggle the problem around. Let's try that again. Identify my index as 4. I'm taking the 4th root of x to the 17th. So, x to the 17th, or excuse me, to the 17th tells me I'm putting a 17 in the numerator over 4 in the denominator. 17 over 4 does not simplify nicely, so I'm not going to simplify it. Okay? And then let's do the last one. Now, in the last one, the index is understood to be 2. 16 is to the 1st, and x is to the 5th. So when I split this up and totally make it happen, I have 16 to the 1/2, because 16 has an exponent of 1, and my index of my radical is 2. And then I have x to the 5 halves. Now, 16 to the 1/2, remember we said 1/2 thinking square root? We might want to actually write this second one as 4x to the 5 halves. Might be a great option because that's what the square root of 16 is. Now we can go the other way. X to the 3/4, that looks like a good one. X to the negative, I don't want to go negative. X to the 5 halves, and 2x all raised to the 6/7. Okay, I'll walk you through the first one. Remember, the numerator tells us what the exponent is. The denominator tells us what the index is. Okay, so when I rewrite this and translate it, right now I'm technically going this way from the order we talked about at the top. I know I'm going to have a radical with an x underneath it. The exponent on that x is 3, and the index is 4. Okay, your turn to try again. You try. Make this happen. I know you can do it, right? Okay, so now you've tried it, right? You've tried the second B and the second C. You probably should call them E and F. But can you identify the different parts? Notice, I have always gone blue in the numerator because that's my exponent, green in the denominator, that's my index. So that tells me when I set up my radical, x, guess what? The numerator is 5, I am doing x to the 5th. The denominator was 2, so I'm doing the square root. Now, the only thing I don't really like about that is this 2. For square root, we don't really want that 2. So we could just leave it this way because it is understood. It is understood that, you know what? When we don't see a number there, that is the square root. Okay, last one. Exponent of 6. So my 2x and my radicand of 2x is to the 6th. And my index is 7. That's not so difficult to make these changes. If you can make the changes going from one way and the other way and so on and so forth, you're going to be fine, right? Just figure out what is my index, what is my exponent, how does that drive my fraction. Because really, once you have it set up with those exponents, all of the wonderful rules for exponents apply, right? Product of powers. When we multiply two powers, for example, a to the m times a to the n, well, we add them. I don't care if m is 1/2 and n is 3/2. We can still add them. Quotient. When we divide a to the m over a to the n, when we divide, we subtract. That does not change for fractions. Okay? Power of powers. Now we got like the whole like exponent, double exponent happening. Okay? And so when we have a raised to the m raised to the n, I don't care if those are fractions, if they're whole numbers, whatever they are, we multiply. None of this is new. We went over it in 1.5. We went over it before we started chapter 7. We went over it probably 2 or 3 times besides those. Okay? Power of a product. So I got two things being multiplied and then raised. So now I got AB raised to the m. That means A is raised to the power of m and B is raised to the power of m. I know you've seen these notes before. And then the power of a quotient. A over B raised to the m is a to the m over b to the m. Okay? All of, let's see, this and this, and really I could probably circle the whole thing, but these are the key rules you've seen before. And let's say, I'm just going to give you a quick example. Even if it's something like, let's just do an easy product one. Let's say I have 4 to the 3 halves times 4 to the 5 halves. I don't want to think about what 4 to the 3 halves, I don't want to think about what 4 to the 5 halves is until I can condense it down so I have one base and one exponent. So I'm going to add 3 halves plus 5 halves. Hint, not 8/4, 8 halves, keep the denominator the same. 8 halves is 4. Right? I should probably write that out so you can see where I'm getting that 4. 8 halves is 4. Now what is 4 to the 4th? Well, 4 times 4 is 16. Times 4 again is 64. Times 4 again, well, that's 256. I had no idea that that was 256 back here. But with a little work, then I got it. And this part of that little bit of work, right here, the adding, that's just from right there. This is nothing new. But you're just doing it with a little bit different numbers. You're doing it with fractions. Who cares? Okay? Make it happen, people.